Welcome everybody. This time around we're going to be looking at the area of a triangle. We'll be looking at understanding how a triangle can be considered as half of a parallelogram. We'll be able to identify the base and the height, which is a perpendicular measurement of a triangle, and we'll also be able to find the area of a triangle. And as usual, our success criteria will be that we can do each of those things that we've just mentioned. Let's begin by looking at our key ideas. So we have one side of a triangle that we refer to as the base. It is often the longest side, but certainly doesn't have to be. We have a perpendicular distance from the base, which goes to the opposite vertex, which we call the height. Now these two together will determine which one is your base and which one is your height. So in the example triangles we have here, you can see we have a base measurement, and then we have a height measurement. The height doesn't necessarily have to be one of the actual sides of the triangle. In the first example, it is, the first one on the left, it is actually one of the sides, but in the other two, we have worked out our height using a dotted line, so a line that's not actually part of the triangle itself, but it is the perpendicular measurement from the base. And again, the vertice or vertex is where two or more lines intersect. So again, we've decided which one is our base, and we've then worked out which perpendicular line, so which 90-degree line from that base would go to the vertice, and that is what gives us our height measurement. So the area of a triangle can be written as a half multiplied by the base multiplied by the height. And of course we can write that in a few different ways. So in the second line there we have half times b times h, so half times base times height, where b of course is base and h is height. We can also write that in the more algebraic form where we remove the multiplication symbols and we just say half bh. And of course we need to also remember that bh over 2, or b times h divided by 2, is the same thing. Remember that we can rearrange multiplication equations because the order that we do them doesn't matter, because they're all multiplied together, so we can end up with those different forms of the area. Now at this point, just again, let's have a little bit of think about this formula. So if we have a square, we talk about the length and the width, but we could also possibly talk about the base and height here as well. So a square would be base times height, okay? A triangle, really, think of it as divided by 2, which is where we basically get the idea of dividing by 2. But in actual fact, it's not just a rectangle. It works for rectangles, of course, but if we think about our parallelograms that we did earlier, which is those rectangles that are tilted a little bit, we always talked about a height as well, okay? A height that had to be 90 degrees to our base. So if we have a base and a height, if we divide this at any point into two triangles, so it has to go from one corner to another basically, then we get half of a parallelogram. And so that is where we get this idea that the area of a triangle is actually half of the area of a parallelogram with the same base and height measurements. So that's the relationship between triangles and parallelograms, and to a further extent also to rectangles. Let's now have a look at the questions that you'll be asked to do. For question 2, you simply have to find the area of each of the given triangles. So in the first one, it's a fairly straightforward triangle. First thing to identify is your base and your height. So we're certainly looking for which one has the, also where the perpendicular sign is. So here we have the perpendicular sign. So we have, this would be our base, and therefore this would be our height here. So if we write out our formula, half base times height, I'll put the area, at the start, we would therefore have the area being half of 7 times 5, okay, so half of, I'm going to do 7 times 5 first, is 35. And of course, half of that is going to be 17.5. Okay, so that would be my area. Don't forget it's meters, because they've been given a unit of measurement. And again, we're talking about area, so it's always squared. In our second example, it's a little bit less obvious, I guess, because what we have is a measurement, and we have this red line over here, which has given us something that's perpendicular at this point. At no point so far does it look like it's in our triangle. We could possibly rotate this around to make it a bit clearer. Unfortunately, I can't do it in this slide. But if we think about it, or if we notice, we've also got these symbols here. And they're indicating to us, and we sort of see it visually anyway, that those two sets of lines, so this dotted line along here and this side along here, these are parallel lines, which means they are always an equal distance from each other. So what that means is if this is a perpendicular or a right angle here, then it is also a right angle in here, which means if I also take this line and I make that parallel, I can also draw it here, for example, and that would give us a clearer indication that this is actually the height for this triangle. So really all they did by drawing it outside is maybe make the triangle a little bit less messy, but it is of course one where you have to notice the parallel lines, and therefore that this red dotted line is actually the height that we're looking for. So this of course becomes our base, and this 1.5 becomes our height. So now let's do our equation. So area equals a half base height, which is equal to half of, what have we got? Base is 6 multiplied by height of 1.5. So it's half of 6 times 1.5. Well, we can do our math over here. If we've forgotten how to do multiplication of decimals, remember you just ignore the decimal place to begin with. So we'll do 6 times 1.5, making sure that we keep everything lined up properly. 5 sixes are 30. 5 nothings, of course, are nothing. Probably bring down the 3 that we had. We're now doing 10, so 1 times 6 is 6. Add them up, 0 and 6 and 3 is 9. So we've got 90, but now we bring in the decimal places that we had. So in that equation, 6 times 1.5, there was only one decimal place. So we only need one decimal place in here. So our final answer of 6 times 1.5, of course, is 9. So now we've got half of 9, and of course half of 9 is 4.5, remembering to use our unit and squared. So here we have an area of 4.5 meters squared. Question 3, find the areas of these triangles which have been drawn on 2 centimeter grids. Give your answers in centimeters cubed. So at first glance you might go, I can't solve these, I don't have measurements. But this drawn on 2 centimeter grid, is the critical part. So each of these blue squares that we can see here is equal to 2 centimeters in length. So what we can in fact say here is that this measurement across here, because it goes over 2 cubes, is 4 centimeters, and this here would become our height. Right? It's perpendicular, so it is at 90 degrees, and it goes up to the vertex. This is the vertex here where we have 2 lines intersecting, and again it goes up 2 squares, so the height would also be equal to 4 centimeters. Okay, so now area equals half of base times height, which is equal to half of 4 times 4, which is equal to half of 16, of course, which is equal to 8. Don't forget that we are measuring in centimeters squared. The second one, again, it's on a little bit of an angle, so we just have to look carefully. But again, we can see we really have a triangle that has a base across here, and it travels over 3 squares, so that is going to be a 6 centimeter length. And then we have a height going up here, because here is our perpendicular 90 degrees, and it travels over 2 squares, so that's going to be 4 centimeters. All right, this is our base, this is our height. So again, area equals half of base times height, which is equal to half of 6 times 2, which is equal to half of 12, which of course is 6, and that is centimetres squared as well. Question 4, we start getting into our worded questions. A rectangular block of land measuring 25 metres long and 15 metres wide is cut in half along its diagonal. Find the area of each triangle of land. So as always, we're looking for the keywords and measurements, and I always strongly encourage you to draw a diagram to help visualize what the question's asking you. So the first thing is we have a rectangular block, 25 metres long and 15 metres wide. So let's just draw ourselves a rectangle over here. It doesn't have to be to any scale. 25 metres long and 15 metres wide. It is then cut in half along its diagonal. So we can see now that it's being cut in half diagonally. Okay, so there we have something that we can now see we have two triangles. Right, there's a triangle at the top and a triangle at the bottom. Find the area of each triangle of land. So we now have a base here, and this becomes our height, because here is our perpendicular or 90-degree angle. So the area of one triangle is half base times height, which of course is equal to half of 25 times 15, which is equal to, now again, I'm not going to do that in my head, so 25 times 15, all right, 5 times 5 is 25, 5 times 2 is 10, picking up that 2 is 12, so I should have drawn that line there. Now we're doing the 10, so 1 times 5 is 5, 1 times 2 is 2, add those up, 0 and 5 is 5, 5 and 2 is 7, 2 and 1 is 3. So that's 375, so I've got half of 375. And again, if I do that, I can do that one in my head. So half of 300 is 150, 75 would be 35, so 185, 187.5. Meters, meters squared. And again, you should probably do that 375 divided by 2 or by half on a calculator, or do the math on the side if you need to, but that's the answer that we should end up with. Now, that's all well and good, and that's probably the best option for this question because we are doing areas of a triangle. But can you see another way to do this? Well, we've got a rectangular piece of land that's been cut in half, right? So another option, we could have simply done area of a rectangle being the length times width, which we could say 25 times 15, all right? So if we do that math, we get 25 multiplied by 15, all right, which we already know from above here is 375. So the area of the rectangle is 375 meters squared. And this is the key word here, it is half. All right, so we can simply say, hey, a rectangle is made up of two triangles if it's divided exactly in half. And again, I'm telling you this or going through this at this point because that again explains why we have this half here. Our area for a rectangle is the same as two lots of triangles. Therefore, the area of a triangle is half what that same rectangle would be. So just a little bit of a sidestep, if you like, to re-emphasize why the formula for an area of a triangle is half of the base times the height, because that is basically half of a rectangle divided in two. So for this question, yes, I want you to do this over here because we're really focusing on triangles, but it's always good to know where formulas come from, and if you can understand that, then it helps you really understand why you're doing the triangle formula. Question 7. A farmer uses fencing to divide a triangular piece of land into two smaller triangles as shown. What is the difference in the two areas? So we need to work out the area of these two triangles, and then we need to work out the difference between them. So if we think about this here, we have one measurement on the side here of 15. We have this smaller triangle having a measurement of 7, and we have this section here having a measurement of 12, which means technically the big triangle from one point to the other would have 7 plus 12 would be equal to 19 meters. And that is important because you can find this big triangle because you now have the base, for example, of 19 meters and the height of 15. And you can find the area of this smaller internal triangle here. So this smaller one here, we'll call this triangle 2, because you have a base of 7, for example, and a height of 15, or vice versa, really. So if you have the big triangle and then you have this smaller T2 as well, then you can work out what's left by taking T2, the smaller triangle, away from the big triangle to find this part that we're going to call T3. T3 is a triangle, but we don't have any measurement that tells us what its height would be. We don't have the skills right now to work out what its height would be, but we do have the skills to work out the big triangle and then the smaller triangle. Okay, so we'll call the big triangle T1. So let's work that one out first. So the area of T1, and that's how we'll write it like that, is equal to half of the base times height. You notice I keep writing the formula just to keep putting in my head to remember it. So it's equal to half of, we'll say 19 as the base, multiplied by 15 on the top, or sorry, the height, which is equal to a half of, well, let's work it out, 19 times 15. 5 nines are 45, 5 ones are 5, plus the 4 is 9, doing 10, so we start with a 0. 1 9 is 9, 1 1 is 1, add them up. 0 and 5 is 5, 9 and 9 is 18, 1 plus that 1 then is 2, so 285. So half of 285. So of course then we get an area of 142.5. And we are talking about meters squared. So our big triangle we've worked out to have an area of 142.5 meters. Now let's do the area of T2. So the area of T2 is equal to, again, half base times height, which is half of base we'll call 7. We're going to keep those numbers the same. So 7 for the base, this measurement here, multiplied by height will keep us 15. So equal to, now 7 times 15. All right, 5 sevens are 35. And then, of course, nothing there, so we bring the 3 down. It's doing 10, sorry, so it's a 0. And then 1 times 7 is 7. Add them up, we get 5 and 10, so 105. So it's going to be a half of 105, which is going to be 52.5 meters squared. So we now have the big area and we have the small area. So the area of T3, so we just write over here, T3 is going to be equal to T1 minus T2. All right, so the big area, big triangle T1 minus whatever T2 said will give us whatever's left for T3. So if we add those numbers in, so T3 at the moment is going to be equal to 142.5, so that's what T1 is, minus 52.5. Let's do that properly. So 142.5 minus 52.5. Remember, we just got to keep the decimal places lined up when we're doing subtraction of decimals. So 5 from 5, of course, is 0. Make sure the decimal point stays where it should be. 2 from 2 is 0. 5 from 4 we can't do, so we take from that 1, so that's 0. Put it here. So now we've got 5 from 14, which of course is 9. So we end up with a measurement for T3 of 90 meters squared. Okay, so the big triangle T1 we're calling is 142.5. The smaller triangle T2 that we had measurements for, we have an area of 52.5. And so T3, the leftover part of this triangle, would be the big one minus the small one that we had, which we have as 90 meters squared. So what is the difference in the two areas? There we go, we have that there. But we should write a worded answer because it is a worded question. Right, so the difference of the two is 90, difference of the two is now. Have we actually answered this? As I'm doing this question, I've realized I haven't actually got the answer. I've worked out what T2 and T3 are now, but I need the difference between those two. I just literally realized that as I was writing the answer out. So the difference of these two would be, what is T2, the difference between T2 and T3? Because they're the two triangles that we've actually got. So what is the difference we're basically saying between 52.5 and 90? Well, let's just do a subtraction. It doesn't technically matter which order we're doing, but we want to not have a negative number right now. So let's do 90 minus 52.5. Now remember, 90 is the same as saying decimal 0. Okay, you can have as many zeros as you want. So we can't take 5 from a 0, so let's borrow from in front of it or take from in front of it. Well, we can't do that. So we take from the 9 and make that an 8, bring that to there. Then we take from that, make that a 9 and bring to here. So now we can do 5 from 10 is 5. Keep the decimal point where we want. Where it should be, I should say. 2 from 9, of course, is 7, and 5 from 8 is 3. And that, of course, would be meters squared as well. So the actual difference between the two triangles, the difference between T2 and T3, as we're calling them, is actually 37.5 meters squared. Now that's a perfect example, and I can pretend that I did that deliberately. I certainly didn't, of thinking that you've answered the question because you've done all this great work, right? And then writing it out, even doing all this great working out, and then realizing that you didn't actually answer it. So always read your question really, really carefully. It wanted the difference in the two areas. This area that we're calling T2 and T3, all right? We needed to find the big triangle to work out the rest of it, but we actually ended up having to do this part up here, the difference between T2 and T3. So that actually had quite a bit to it, didn't it? So quite a bit on the screen there. Hopefully that made sense. You might want to watch this one back a couple of times to really get what we did, maybe. Okay, question 8. A yacht must have two of its triangular sails replaced. So we know we're talking about triangles now, which is very important. One sail has a base length of 2 meters and a height of 8 meters, and the bigger sail has a base length of 3 meters and a height of 14. If the cost of the sail material is $120 per meter squared, find the total cost to replace the yacht's damaged sails. So again, let's look for the keywords and do some diagrams. So we've got two triangular sails, so we're going to have two triangles. I'm just going to draw two basic triangles, nothing special about them. I just chose to draw triangles like that. I do want right angled triangles though. And if you think about sails, you probably realize that's sort of the shape that they're talking about. So the first one has a base of 2 meters and a height of 8 meters. And let's call this one S1 for sail 1. So this will be sail 2. So this sail, the bigger one, has a base of 3 meters and a height of 14 meters. Okay, so the first thing we need to find is the area of both of these. So the area of sail 1, so again we'll write it like that, is equal to half times the base times the height, which is equal to half times 2 times 8, which is equal to half of 16, which is equal to 8 meters squared. And then the area of sail 2, the bigger one, is the same, half times base times height, which is equal to half of 3 times 14, which is equal to half of 42, which is equal to 21 meters squared. So we now know the area of both sails. But we're going to want to know the cost to replace both sails. So to work out the cost for both, let's just add them together now. Let's find out the total area for these two sails. All right. So let's say area total is equal to the area of sail 1 plus the area of sail 2, which of course is going to be 8 plus 21, which is going to be 29 meters squared. We're still talking about area here though, so we've got 29 meters squared. It then tells us that the cost of the material is $120 per square meter. Okay, so to find the total cost, we now have to say the total cost, all right, is equal to the area that we have for the total multiplied by 120, okay, which is equal to, we worked out the area for total at 29 times 120. Again, let's do the math over here. So 120 multiplied by 29. Again, it doesn't matter because it's a multiplication. I just always prefer the smaller number as a second if I can. So 9 times 0 is 0. 9 times 2 is 18. 9 times 9 is 9 plus 1 is 10. We're now doing 10, so we start by 0. 2 zeros are 0. 2 twos are 4. 2 ones are 2. We'll add them up. 0 and 0 is 0. 0 and 8 is 8. 4 and 0 is 4. 2 and 1 is 3. Right, so we now have a total area of 3480 meters squared. Okay, 3,480 meters squared. Sorry, take that, it's not meters squared. Sorry, this is, we're doing dollars, aren't we? So 3480 dollars, all right? So equals dollars 3480. Sorry about that. I forgot because I didn't write it down anywhere that we were talking about $120. Yeah, so $3,480 is how much it will cost to buy the material to replace these sails. But of course, it is a worded question, so we need a worded answer. So the total cost to buy the material is $3,480. If you want to be really, really accurate, .00 to include the cents component, even though it's not actually part of it. And again, the math itself is not particularly complicated. It's more about recognizing you've got two triangles that you had to find the area of. You then had to find the total area of that, and then you had to multiply that total area by the $120 to find out the total cost. So there's several steps there. None of them by themselves are complex, but you do have to work out the correct order to do things so that you can actually get a final answer at the end. And that is it for this particular lesson. As always, thank you for watching. If you need to re-watch this and re-watch any of those questions more than once, by all means do that. And if you really get stuck, please get in contact.